Well, greetings, everyone. I am joined by Dr. Simon Lee. He's a postdoctoral research assistant there at Columbia University, and he hails from the UK. And he has his specialty in stratospheric polar vortex unit, stratospheric meteorology. And we are very happy to have him back here. We had him on a couple months ago to talk through some of the myths of the polar vortex, and we're happy to have him here in the middle of October 2022 to talk through what he feels will be the state of the polar vortex going through the wintertime. So thanks for joining us today.
Thank you for having me. It's great to be back, and it's hard to believe that here we are in October again.
Yeah, exactly. Yeah, we made it through the summertime, and now we're looking at the polar vortex. And this is the key time actually to look at the state of the vortex and some of the trends to see maybe what could happen through the wintertime. So I'll share my screen here, and maybe you could talk about what we've seen so far with the polar vortex since it came to fruition or started to develop in the later part of August, early part of September.
Yeah, so for the most part, what you can see there with the red, the pink, and the orange lines is kind of where we are and where we're going so far. And versus what we normally would expect, which is the black line and the gray shading, the vortex has been relatively close to normal. There's been no huge departures there. There was this brief period, well, I guess just around now and a few days ago, where the winds were on the weaker side of what we expect. So sorry, I've just realized that I didn't realize what pressure level we were looking at. So this is at 100, right?
Yes.
Yeah, so this is in the lower stratosphere. The level just above the tropopause, where these winds kind of directly influence the troposphere below. If you change that 100 to 10, we could go up into the mid-stratosphere and look at the core of the vortex.
There we go.
That makes more sense. And so this is up at 10 hectopascals, about 30 kilometers, and it's the typical level which the stratospheric vortex strength is defined at. And there you can see a bit more clearly that little wobble that we had a few weeks ago, where the vortex went down to, well, according to this climatology, at least record weak since 1979, I believe, per this MERA 2 climatology. And so that was interesting, but then it rebounded closer to normal. And as you can see, actually, in the blue line, which is last year, you can see that vortex also went close to record weak in mid to late October. And then, things turned around very quickly, and that vortex just carried on strengthening all the way through until late February this year. So I think these little early season wobbles can sometimes not be a good guide to the future. So overall, where we've been so far, nothing too out of the ordinary, I would say. And we also saw that down at 100, which is just above the troposphere.
Now, when we look at the GFS Northern Annular Mode Index, this is just a short-term trend through the end of the month. Do you see any indication in this particular data that we're going to favor a stronger polar vortex or a weaker polar vortex going through the first part of November?
This is interesting because the Northern Annular Mode, which is this kind of leading diagnostic mode of variability across the Northern Hemisphere, that's essentially a guide to the strength of the westerly winds. And so when it's in a negative state, we generally expect weaker westerly winds and more meandering flow. As you can see through the kind of browns and reds, it's been mostly in a negative phase since, in the troposphere at least, since August, which is when this time series begins. And then even into the forecast as well, it's still mostly on the negative side, and this extends upwards into that lower stratosphere area. But at this time of the year, it's less a case of something coming down from vortex variability that we see in the midwinter when we're thinking about things like sudden warming events. This is more just that the troposphere is kind of extending its influence upwards a little bit.
Okay.
But it is interesting that that's kind of been so blocked. In essence, they're so negative, a negative NAM state for so long, and certainly that suggests that there's some large-scale pattern which, if it were to continue into the early part of the winter, would be conducive to a colder and more blocked start to the winter, which we can talk about a bit in a minute when we get to the seasonal outlook.
Yeah, when he says a block pattern, he means large north to south utilizations in the jet stream that would bring the cold air south. And
Yeah.
that's an example of a blocking pattern. And now we take a look at this is from last Thursday, the 10th of October, 13th of October. This is the forecast from the European model showing the strength of the winds around the polar vortex. The stronger the winds are around the polar vortex, the less likely cold air is to move south. But as you can see, there's some utilizations going through November. Can you talk us through what the European model is showing maybe for the next couple of weeks with respect to the polar vortex winds?
So again, this is something that looks fairly close to normal, which is if you compare where the thick blue line is, which is the average of all those 51 ensemble members versus the red line, which is the climatology, you can see that realistically it's very close to normal. But the elephant in the room when saying that is there's an enormous amount of spread in that forecast.
Yes.
Now, I'm not sure what the normal amount of spread to see in the forecast in October in using this model version is. But the thin red lines either side of that blue, the spaghetti of blue, they are the 10th and 90th percentiles of the model's climate. And so that is a very large spread to have it going all the way out there. And you've even got this one member out on its own at the bottom near Thursday 24th.
Yeah.
That's actually a major sudden warming at that point.
Yeah, when it goes below 0 miles an hour, yeah.
Yeah. So you do have this huge uncertainty. And so whilst the average is kind of close to normal, clearly the one thing that I would want to emphasize when saying this is that the ensemble mean is not something you ever expect to actually see happen. It's just an average of various solutions. The real world, what we see over the next 6 weeks, the real world will hopefully trace out what one of these ensemble members is actually predicting. And at the moment, that's essentially kind of no signal. There's essentially no predictive signal in the vortex strength. So whilst the best guess is normal based on this, clearly there's huge uncertainty. So I think that's the thing to bear in mind. And you can see that spread in those U winds, in the amount of spread in the blue lines rapidly grows between 27th October and 3rd of November.
Yeah.
You can see that moment where it just explodes in the uncertainty. And so maybe around that time, whatever process, whatever set of atmospheric evolution, whatever way the atmosphere decides to evolve at that point, once that's happened, maybe the spread, the uncertainty will reduce, because clearly something around then is making this uncertainty just blow up. And then it remains uncertain from then on. So it'll be interesting to revisit at the end of the month.
Is it normal to have this much uncertainty this early in the season?
I have seen uncertainty like this before, but this does seem particularly extreme, and it's been there for a few runs now. But it can happen. It can happen.
And then taking a look at the European forecast, this shows the entire length of the season. The polar vortex is active, which is from the late part of the summer all the way into the springtime. So maybe you could talk through what we're seeing here with respect to the strength of the stratospheric polar vortex through the winter. Yeah, just from this one model.
Yeah. So this is again a similar figure to the previous one, except this is almost essentially the same idea, but the model is run for longer. Now, the one thing to really to focus on here is that the thick black line is the climatology from the observations, or from ERA 5 reanalysis. Buried under everything, there is a thick orange line, which is the model's climate. Now, what you'll notice there is that the model's climate is lower than the ERA 5 climate, which means the model has a bias toward having a weaker vortex than the real world over the same time period. So when we're looking at the thick blue line, which is the average of all those 51 ensemble members, we should be comparing that with the thick orange line, which is the model's mean state, not the thick black line, which is the real world's mean state. And if you don't do that, then what you could end up doing is looking at this forecast and immediately going, well, the model is predicting a much weaker vortex on average than the real world. But in fact, that would be true, but an incorrect conclusion, because you want to compare it with what the model predicts by default. Yeah. And again, what you can see in this forecast is that the ensemble mean is very, very close to the model climate mean for most of the winter, until you get toward February. So really, there's not much of a forecast of anything particularly noteworthy happening until we get later in the winter, where the model starts to predict a stronger vortex than both its climatology and even stronger than the Era 5 climate. And that's not unexpected, given some of the large-scale background conditions that we have. We have a La Nina in the Pacific for the third year running, and that tends to favor a stronger vortex later in the winter. We also have a descending westerly QBO, quasi-biennial oscillation, in the tropical equatorial stratosphere. And that, by the time those westerlies have reached further down into the lower stratosphere later in the winter, would help to favor a stronger vortex later on. So this overall evolution kind of matches with what I would expect to see. But one thing that is, I think, you should probably note when looking at this as well, is that the number of members which go for a reversal of the wind, so that drop below that dashed line, it's actually not that many until perhaps January. And even then it's only a few, but realistically, you've only got one big warming happening before January. So the model does not have a strong indication of a major sudden warming happening early on.
And if we go back to last October, of course, we know from the previous slide that we had a very strong polar vortex through the winter. This was the forecast in October, looking through the winter time. And as you can see, the average of the ensembles was showing a weaker than average polar vortex compared to not only the climatology, the regular climatology with the thick black line, but the model climatology too. So, and we know that in reality, it was way above the ERA 5 daily climatology. So, last year there wasn't much indication early in the season that it was going to be accurate, I guess.
It definitely evolved a bit differently. I think if you go to the November 2021 forecast, then I think if memory serves,
there it is.
That it started to drift toward getting a stronger vortex later on. And then if you go to the December 2021, it feels like you're almost cheating at this point because you're getting into the winter itself. But I think this one then did. Yeah. That one then did. So something, that was the one I remember. Something changed essentially in what the model knew from the initial conditions during that time. And by the time we got to December 1st, 2021, that model was set. That was an incredibly strong forecast there from this run. And actually, if you look, you can see that some of the ensemble members in the thin lines actually exceed anything that the model had predicted in its reforecast climate. Some lines go even beyond what the peak in the model climate max is. And of course, we did then see, an incredibly strong vortex through the latter part of that winter. So it does show that, models can pick up on signals. They can really converge on a solution as we move through the next month or two.
And then if we take a look at the most recent sea surface temperature anomalies, I know in the podcast we did a couple months ago, you indicated that sometimes large scale systems that reach well up into the troposphere can actually impact the stratospheric polar vortex. And we see a big bubble of very warm water in the North Atlantic and North Pacific. Do you think that could have any implication on winter storms that could potentially become strong enough to impact the stratospheric polar vortex or cause some of that coupling?
It's interesting. It's an interesting question to raise. So there was a study that was published earlier this year, which actually linked a bomb cyclone, a rapidly deepening cyclone in the North Pacific, to the onset of the sudden stratospheric warming in early January 2021. Through its upward propagating wave activity that it generated, which knocked the vortex around. And so one of the things which can intensify mid-latitude cyclones is a large source of heat from the ocean, as long as that is then coincident with colder air from the polar regions to create a region of enhanced temperature gradient, a strong baroclinic zone. Now, if you have the incredibly warm anomalies that are going on there south of the Aleutian Islands, that's pushing 5 Celsius as an anomaly. That's amazing, especially when you see it juxtaposed with the La Nina crossing the Pacific. I think it's an amazing animation to look at. So that actually is a region where you have climatologically big cyclogenesis happening. This is near where the cyclones deepened in late December 2020. that then led to the onset of the sudden warming a week later. And so actually, if that were to persist, and sea surface temperature anomalies do tend to persist for a very long time, then yeah, this could certainly act to amplify mid-latitude storms, which is actually probably a more consequential thing to think about just from the perspective of what they do in the troposphere, not just what they may do to the stratosphere.
Yeah, and then if we look at last year, that was totally different. We had a cold pocket of water along in the Gulf of Alaska. So we still had that warm pocket in the North Pacific, but adjacent to that, we had a very large pocket of very cool water in the Gulf of Alaska. We also had a little bit of cool water here south of Greenland. So things have really changed, or things have really flipped, I guess, in the North Atlantic and North Pacific compared to where they were last year at this time, I guess, right?
Yeah, there's some similarities, I think, if you flick back between them. Certainly, there's the blob in the North Pacific in both. The one in the map from last year is kind of closer to the sea surface temperature anomaly pattern that you expect in the Pacific, at least, from the positive North Pacific oscillation, which tends to consist of lower pressure just north, lower than normal pressure just north of the Aleutian Islands and sort of west of Alaska, and a higher pressure just south of the Aleutian Islands.
Okay.
And what sort of developed through through into December 2021 was this huge persistent ridge that just existed in the North Pacific. And it may have been forced possibly by the strong positive sea surface temperature anomaly that we saw there. And actually, I think that probably played a role in suppressing the amount of wave activity coming out of the troposphere, which then helped the vortex to strengthen through the remainder of the winter. So I think overall it's difficult to be too conclusive from the sea surface temperatures. I think the main takeaway is, we have a La Nina again.
Yeah, a triple dip, which are very rare, as we know.
Yep.
Yeah, there's some model, indications that La Nina could maybe dissipate as we go throughout the winter time, to maybe like a neutral pattern towards the middle or end of winter. But isn't it true that it takes a while for the actual weather patterns to adjust when you get away from a La Nina?
Yeah, there's something to be said for that. I think if it's not a rapid response thing that everything just goes back away. So I think if the La Nina did start to weaken off through the winter, the damage in essence to the global weather patterns has kind of already been done in some ways. So that's not something that you expect to really rapidly change on these short-term timescales.
And if I go back here to this, and this is the look at the 10 hectopascal, and as Dr. Lee was mentioning, this is the trend of the winds around the stratospheric polar vortex from last year. So I switched it to 2021, and this is the big rapid strengthening of the polar vortex that we saw during the middle of the winter. And then it looks like we had a pretty dramatic stratospheric warming event at the end of the season because it was so strong during the middle and end of winter. You mentioned before that if you have this sudden drop in winds with the stratospheric warming event happening, towards the end of the season like this, that can actually have a big implication on the weather pattern when it makes that marked drop in strength, correct?
Yeah, absolutely. That can happen in midwinter and be kind of formally called as sudden stratospheric warming, or when it kills the vortex at the end of the season, as in this case, it's a final stratospheric warming. And in this case, it was largely a dynamically driven event. It wasn't just the vortex kind of dissipating because the sun had returned to the pole. As you can see from the rapid deceleration of the winds, this was driven by dynamics of waves breaking in the stratosphere, and that can lead to the same kind of negative northern annular mode pattern, these disruptions to the jet stream that we see in midwinter, although not quite the same, not least just because the resources of cold air that can bring the cold air outbreaks that we know tend to follow sudden warmings in midwinter. Mm-hmm. But that not only are those depleted because we're getting into March, April, but the jet stream in the troposphere is in a different place because we're further through the winter, we're moving into spring. And so the results are a little bit more mixed than they are in the midwinter. But yeah, they can be a source of disruption to the weather and a source of predictability too.
Yeah, and if we have a final warming event that dramatic, it can also impact the start of the growing season. If it's been pretty mild, like for an early part of spring, and growers are out there planting, and then we get this sudden change in the weather pattern where it brings cold air, it can bring a freeze, a late spring freeze, and that can really impact the start of the growing season. So even though it might not have implications with a large winter storm, it can have implications with cold weather that delays or infringes on the growing season. So that might be one indication.
Very much so. There's also the lesser talked about thing, which is the vortex. Inside the vortex, even in the northern hemisphere, and even now as you move into spring, it's an ozone poor region. So this is an area where ozone can't be transported across the edge of the vortex. It's essentially a transport barrier. And so inside the vortex, you end up with a region of very low ozone. Not as low as in the Antarctic, because the northern hemisphere vortex isn't stable enough. It doesn't get cold enough typically to cause that amount of ozone loss. But it does cause it to an extent. And so when you have these springtime disruptions to the vortex, what you can end up with is that ozone poor air making its way into the mid latitudes where people live. And so you can end up with higher ultraviolet radiation risk when this vortex is broken apart in the spring, especially if it was strong beforehand. And that was something we were concerned about a little bit with this winter in 2021-22, because the vortex had been cold and strong, and so there was more ozone depletion potential than in a normal winter. But the way it kind of fell apart towards the end of the season, it got rid of that to an extent. But it's just something else to think about.
This past winter in the Southern Hemisphere, I believe there was some pretty large fluctuations in the Southern Hemisphere stratospheric polar vortex. Is that correct?
So if you change the N in the URL after the U60, you can change it to an S, and you can flip it to the Southern Hemisphere version of this figure.
Okay. Yeah.
So that's just 2021.
Yeah, so if I change it to 2022 here.
Yeah, so this is in blue is where we were last year. This is centered, of course, on our summer, JJA, and then the red and pink is where we were, where we are now and where we're going. And yeah, I mean, through the summer of 2021, that vortex was a little bit weaker than normal, and then it was very strong very late, which I think caused enhanced ozone depletion. As we went towards sudden summer with a colder, stronger vortex, there's greater risk of that. And we're kind of on that strong side now in the Southern Hemisphere as well.
There's probably no predictability between what happens with the Southern Hemisphere stratospheric polar vortex in their winter, and consequently what happens with the Northern Hemisphere polar vortex in the Northern Hemisphere winter, correct? There's probably no correlation there.
It would be beautiful if there was, but no.
Right. Okay.
In general, I was just going to say, in general, the Southern Hemisphere vortex doesn't really actually do anything of much interest to warrant predictability. As you can kind of see from the shading, the width of the gray shading is very narrow in the Southern Hemisphere. That vortex is really stable, and so even if you kind of drop out the bottom 10%, as we did this year, where that red line goes down, the deviation in terms of the absolute deviation in terms of meters per second is tiny compared with the standard deviation of the winds in the north.
Yeah, there's definitely more fluctuation with that. Yeah, that's definitely quite visible. All right, any final thoughts here? I'll get back to the two of us here. As we look at the polar vortex, any final thoughts you have on going through the winter? I noticed you talked about some blocking early in the winter, and that could potentially impact the vortex, some potentially strengthening of the polar vortex a little bit later in the winter. So any other thoughts that you might have on going through the winter with the polar vortex that we haven't talked about yet?
In general, I think that's kind of how how I see the winter evolving. But the thing is that this is the third year of La Nina. It's the third year with kind of a generally similar things going on.
Right,
And
exactly.
the previous two winters have been very different in the way they've evolved. We had the sudden warming in the middle of winter 2020-21 that changed everything. Last winter, this vortex went very strong. There were kind of numerous reflection events that helped lead to the Alaskan ridge being quite dominant for North America, and colder weather in the back half of the winter versus the first half of the winter in the US.
Yeah.
And so it's difficult because we have forecast models which have been saying similar things 3 years running,
Yeah.
and they've not, done particularly well because they have this very large scale pattern that's telling you one thing, that's the same, and so it's just rinse and repeat from that predictive signal.
Yeah.
And I think in general, when we get this time next month, we'll know more, and that's when everybody kind of puts their money on the line, sometimes literally,
Right.
for what the winter is going to do. If it was me expecting it, the one thing that seems to have not happened in the stratosphere for several years now is not very much. We've had strong vortex, we've had sudden warmings. It's a strange thing, and it's a gambler's fallacy, but we seem to be overdue a winter when nothing of any interest happens.
Mm-hmm.
And so maybe my money is on nothing interesting happening.
Okay.
And this being generally a tropospheric-led winter, which will probably evolve toward a more mobile pattern as the winter progresses. That's where I'm currently thinking. But there's definitely a lot of subjective thinking in there.
Yeah, and like you said, there's other things that influence the troposphere, not just the polar vortex. I mean, of course, last year we had a very strong polar vortex in the middle of the winter, and then we had this cold outbreak in the United States in January that was totally independent of the stratospheric polar vortex, with this Alaskan ridge regime set up, and there was some cold air and some snow from the middle of January into the first part of February that was totally unrelated to the stratospheric polar vortex. So yeah, we'll just have to watch those patterns going through winter. But with the blocking that we're seeing in some of the data, there could be maybe a colder start to winter versus last year, which December was pretty much non-existent in terms of winter across the northern hemisphere. Well, at least North America.
Yeah. No, I agree. I would imagine that December will be a colder start to the winter. I will be in Chicago in December. So well, at least for a week, it's the AGU conference. So there'll be a lot of atmospheric scientists in Chicago complaining about how cold it is, probably. But yeah, I think you are right to say, the stratosphere is great, the vortex is great, it's a great source of predictability, but it's not everything. It's not a deterministic predictor. For every stratospheric vortex state, you can have a wide variety, a whole spectrum of things happening in the troposphere. You can have things, you can have the same weather pattern happen in different states of the stratospheric vortex. And the Alaskan ridge is kind of one of those. And so it's important to not just focus on that. So yeah, it can be 2 weeks of a tropospheric-led pattern in the middle of winter can be the thing that's memorable about the winter, the thing that really leads to that main weather impact. So
yeah,
that can outlast any, in people's imaginations and in terms of the impacts, it can outlast any impact from the stratosphere.
yeah, exactly. Just like with the hurricane season, if Ian is the only storm that impacts the U.S., people are going to remember it and say it was it was a worst hurricane season I ever lived through if they live in Florida. So same implication, but with the wintertime. If there's a blizzard along the East Coast and it bring, like in 2016, that was the only storm, but it brought the entire East Coast above average for the winter with that one storm. So you're right.
Yeah.
What it takes.
Absolutely.
Well, thank you so much for joining me today, Dr. Lee. I really appreciate your insights, and we had some great conversation, and hopefully people will get a better understanding of the stratospheric polar vortex, and that it's not the only guide to what the winter is going to be like, but we gave some insight into the forecast that we think for the upcoming winter. So thank you so much. I appreciate it.
Thank you. You're welcome.